Hello, good morning. So today's lecture will be on the introduction to metamorphic rock. In this lecture series, I will be discussing each and every metamorphic rock in detail. So the first metamorphic rock we discuss here is a quartzite. So what's a quartzite? It's nothing but it's a non-foliated metamorphic rock generally comprises greater than 90% of quartz, and sometimes it can reach up to 99% of the quartz. So they are the largest and purest concentration of silica in the earth crust, and it forms when a quartz rich sandstone is altered by the heat, pressure and chemical action of a metamorphism. As you all know, when a sandstone is converted to quartzite, the characteristic quartz grain crystallizes along with the former cementing material to form a interlocking mosaics of quartz crystals. This results in a network of interlocking quartz grains of very incredible power, and most or all of the unique texture and the sedimentary structures of the sandstones are erased through the metamorphism, and the grainy sandpaper like surface turns into glassy in the looks. And some minor amounts of former cementing substances such as iron oxides, silica, carbonate, and clay often migrate during the recrystallization, and these causes streaks or lens to shape in this quartzite. The interlocking crystalline structure formed in the quartzite makes it very hard, tough, and durable rock. It is so hard and tough that it breaks through the quartz grain rather than breaking along the boundaries between them. Although a quartz-rich sandstone can look similar to quartzite, a fresh broken surface of the quartzite will show breakage across the quartz grain, whereas the sandstone will break around the quartz grain. So, most of the quartzite forms during the mountain building events at convergent plate boundaries, where sandstones is metamorphosed into quartzite while deeply buried. And the compressional forces at the plate boundary fold the rock and thicken the crust into a mountain range. And quartzite is one of the most important type of rocks in the folded mountain ranges throughout the world, and it is one of the most physically durable and chemically resistant rock found at earth's surface, so that when the mountain ranges are worn down by weathering and erosion, the less resistant and the less durable rocks are destroyed, but the quartzite remains there. This is the reason why quartzite is so often the rock found at the crest of the mountain ranges and covering their flanks. And quartzite is also a poor soil former, unlike feldspar, which break down and form clays, and the weathering debris of quartzite is quartz. It is therefore not a rock type that contributes very well to the soil formation. For this particular reason, it is often found as a exposed bedrock with little or no soil cover. So, as I have said earlier, it is completely consists of quartz, and quartzite usually it is white to gray in color. Some rock units that are stained by iron can be pink, red, or purple, and other impurities such can cause quartzite to be yellow, orange, brown, green, or even blue. And so, what all are the uses of such a very hard and durable rock? It is used for making bricks and other strong building materials. It is also grown in popularity as a decorative stone and has limited use in as a crushed stone. As it is too hard, the quartzite is not quarried as much as other softer rocks, and it tends to be taken from the surface rather than underground. It is quite dense and extremely hard that the crushed quartzite can be used in railroad tracks because it is so hard and durable. And it is extremely versatile and can be used both indoor and outdoor. Since it is very durable and less resistant to weathering, it is an extreme versatile rock that can be used both indoor and outdoor. It can be used in so many different shapes, forms, including landscaping, building stone, feature walls, tiles, or even as stone cladding. it is so hard and so resistant that it will not alter to any other. So the next type of rock that we are discussing here is a slate. Unlike the quartzite, slate is a fine-grained foliated rock. It is a homogeneous clayey metamorphic rock that cleaves or in other words splits readily into thin slabs having great tensile strength and durability. So there is a rule that true slate do not split along the bedding plane but along the planes of the cleavage, which may be intersecting the bedding planes at high angle. Unlike the quartzite, slate was formed under low-grade metamorphic condition that is under relatively low temperature and pressure, and the original material was a fine clay. Sometimes it may contain some sand or volcanic dust and usually forms the sedimentary stone such as mudstone or shale. The parent rock may be only partially altered so that some of the original mineralogy and the sedimentary bedding are preserved. The bedding of the sediment as originally laid on may be indicated by alternating bands sometimes seen on the cleavage faces. And the cleavage is the superinduced structure, that is the result of a pressure acting on the rock at some time when it was deeply buried beneath the earth's surface. On this account, slate occur chiefly among older rocks, although some occur in regions where comparatively recent rock has been folded and compressed as a result of mountain building movements. The direction of cleavage that is present on the slate depends upon the direction of the stress applied during the metamorphism. So we have discussed in our earlier class about the slaty cleavage. The foliation in slate is caused due to the parallel orientation of platy minerals in the rock, such as microscopic grains of clay minerals and mica. And this parallel mineral grain alignment gives the rock an ability to break smoothly along the planes of foliations. And the people exploit this property of the slate to produce thin sheets of slate that are used in construction projects and manufacturing. And so what's the composition of the slate? So it is composed mainly of clay minerals or micas depending upon the degree of metamorphism to which it has been subjected. The original clay minerals in shale alters to mica with increasing levels of heat and pressure, and the slate may be mainly composed of mineral quartz, muscovite or illite, often along with the biotite, chlorite, hematite and pyrite. And to a less frequent extent, it may have apatite, graphite, kaolin, magnetite, tourmaline, zircon or as well as feldspar. So as you can see in the figure, most slates are gray in color and range in continuum of the shades from light to dark gray. And the slate also occur in shades of green, red, black, purple and brown. And the colors of slate is often determined by the amount and type of iron and organic matter that is present in the rock. We have discussed so many things, and we have discussed that quartzite has been formed in the compressional tectonic margin. So what will the environmental formation of the slate? The tectonic environment for producing slate is usually a former sedimentary basin that become involved in a convergent plate boundary, and the shales and mudstone that are in the basin are compressed by the horizontal forces with minor heating, and these forces and the heat modify the clay minerals into shale and mudstone, and the foliation develops at right angles to the compressive forces of the convergent plate boundary to yield a vertical foliation that usually crosses the bedding plane that existed in the shale. And due to this particular slaty cleavage, it is mostly mined throughout the world for producing roofing slates as well as a paving stone. So with this, I am concluding my lessons on introduction to metamorphic rock. In next lesson, we can discuss another two rocks. Thank you. If you have any doubt, please feel to contact me. Thank you.